two people, both living with the exact same genetic condition, both carrying that same extra copy of chromosome 21. And yet, when it comes to one of the most fundamental biological capabilities a human being can have, the ability to have children, their experiences are completely different. Women with Down syndrome can become pregnant. They can carry a child. They can give birth. But men with Down syndrome, in nearly every documented case, cannot father a child. Same condition. Entirely different outcome. Why? That question is what we're exploring today. And the answer takes us deep into the biology of reproduction, the mechanics of chromosomes, and one of the most striking examples of biological asymmetry that science has ever uncovered. To understand why this difference exists, we first need to go back to basics. We need to understand what Down syndrome actually does inside the body, not just to the face or the brain, but to the entire reproductive system. And we need to understand why the process of making sperm and the process of making eggs are so fundamentally different from one another, even though both are ultimately trying to accomplish the same goal. Let's start there. Let's start with reproduction itself. Every human being begins life from a single fertilized cell. That cell is created when a sperm cell and an egg cell come together. But here's the thing. Sperm and egg cells are unlike every other cell in the human body. Most of your cells carry 46 chromosomes, but sperm and eggs carry only 23, half the usual number. That's intentional. When sperm and egg combine, their chromosomes merge. 23 plus 23 equals 46. A complete new human blueprint is formed. The process of creating these special half-chromosome cells is called meiosis. And this is where the story gets important, because meiosis works very differently in male bodies versus female bodies. And those differences are exactly why Down syndrome affects male and female fertility in such drastically different ways. In female bodies, the process of creating eggs begins before a girl is even born. While still in the womb, around the 5th month of fetal development, a female baby already has all the egg cells she will ever have in her lifetime. These cells don't fully mature yet. They're placed in a kind of biological pause, suspended in an early stage of development, and they stay that way for years, for decades in some cases. Only when a woman reaches reproductive maturity do these cells finish their development, one at a time, cycle by cycle, across her reproductive years. In women with Down syndrome, this process, while more complex and while carrying additional risks, still functions well enough to result in viable pregnancies. The eggs that are produced are not always normal. In fact, roughly half of the eggs from a woman with Down syndrome may carry that extra chromosome 21 themselves. This means that if fertilized, those eggs could result in a child who also has Down syndrome. But, and this is the key point, the egg production process itself is not completely disrupted. Enough eggs are produced, enough of them are viable, and enough of them, when fertilized, can result in a healthy, typically developing child. Now let's talk about what happens in male bodies. And this is where the biology diverges in a very significant way. In male bodies, sperm production is not a process that begins in the womb and pauses for decades. It's the opposite. Sperm production is continuous. It never really stops. From puberty until the end of life, the male body is constantly, relentlessly producing new sperm cells, millions of them, every single day. In fact, a healthy male body produces roughly 15 million to 300 million sperm cells per milliliter of semen. The sheer volume is staggering. But this continuous high-volume production comes with a cost. It requires a level of cellular machinery precision that is extraordinarily sensitive to disruption. And that extra copy of chromosome 21 DAO, that third copy that defines Down syndrome, disrupts that machinery in a very specific and very significant way. Here is what happens. The extra genetic material on chromosome 21 interferes with the hormonal signals that regulate sperm production. Specifically, it disrupts the hormonal axis that connects the brain, the hypothalamus and the pituitary gland to the testes. Under normal circumstances, these parts of the brain send out carefully calibrated hormonal signals that tell the testes how much testosterone to produce and when to begin and maintain sperm development. But in males with Down syndrome, this communication system is frequently impaired. The signals get distorted. The hormonal environment inside the reproductive system becomes imbalanced. And as a result, the testes either produce very few sperm cells or produce sperm cells that are structurally abnormal, or both. This condition is known medically as azoospermia, the complete or near-complete absence of sperm, or oligospermia, which refers to an abnormally low sperm count. Studies have consistently found that the vast majority of males with Down syndrome fall into one of these two categories. And it doesn't stop there. Even in the rare cases where some sperm are produced, those sperm often have structural problems, abnormal shape, poor motility, meaning they don't move correctly, that make fertilization essentially impossible under natural conditions. But why does this happen specifically in males and not in females? Why does the extra chromosome disrupt sperm production so severely while leaving egg production at least partially functional? The answer comes down to volume, speed, and biological sensitivity. Remember, the female body doesn't need to continuously manufacture new egg cells. The eggs were already formed before birth. They sit in a state of protected suspension, shielded from many of the ongoing biological disruptions that could affect a continuously running production line. The hormonal disruptions caused by the extra chromosome do affect the female reproductive system. Women with Down syndrome do have higher rates of hormonal irregularities, irregular menstrual cycles, and reduced fertility compared to the general population. But the core infrastructure, the eggs themselves, formed decades earlier, can still function often enough to allow pregnancy to occur. The male body has no such protection. Sperm must be manufactured fresh, constantly, in enormous numbers, through a highly choreographed biological process that runs continuously every single day. That process is far more exposed to disruption. It requires a precisely tuned hormonal environment, and the extra genetic material from chromosome 21 throws that environment significantly off balance. The result is that the continuous production line, the factory, so to speak, either slows to a near stop or produces defective products that cannot do their job. There is also a structural element at play. Research has found that males with Down syndrome frequently have smaller testicular volume compared to the general population. This is directly related to the hormonal disruption caused by trisomy 21. When the hormonal signals that regulate testicular development are impaired from early on, from puberty itself, the testes may not fully develop in terms of their sperm-producing capacity. The physical infrastructure for large-scale sperm production simply doesn't reach its full potential. Now, it's important to be precise here, because science always requires precision. Documented cases of males with Down syndrome fathering children are extraordinarily rare, but they are not entirely without precedent in the medical literature. A small number of cases have been described where a male with Down syndrome appeared to have fathered a child. However, in the scientific community, these cases are considered exceptional outliers, and they may be complicated by questions of chromosomal mosaicism, a form of Down syndrome where not every cell in the body carries the extra chromosome, meaning some cells may function typically. In standard trisomy 21, the most common form, biological fatherhood is considered, for all practical and medical purposes, not achievable. So where does this leave us in terms of the bigger picture? What we have here is a remarkable example of how a single genetic variation, just one extra copy of a single chromosome, can ripple outward through the entire biological system in ways that are not uniform. It doesn't affect every function equally. It doesn't affect every system equally. And it certainly doesn't affect male and female biology equally when it comes to reproduction. For women with Down syndrome who do become pregnant, the medical journey comes with real considerations. There is an elevated risk of the pregnancy resulting in a child with Down syndrome, roughly 30 to 50%, depending on the specific chromosomal situation. There are also higher rates of miscarriage. Prenatal care and genetic counseling are critically important for women with Down syndrome who are pregnant or considering pregnancy. But the biological capacity, the basic ability to conceive and carry a child, remains present in a meaningful number of women with Down syndrome. For men with Down syndrome, the situation is different. And while this can be a deeply personal and sometimes painful reality, it is important that it be understood clearly, both by individuals and by the families and communities that support them. Awareness allows for better support, more honest conversations, and more compassionate understanding. It's also worth noting that fertility is only one dimension of a life. The vast majority of what makes a life full, rich, and meaningful, connection, creativity, contribution, love, friendship, purpose, has nothing to do with the capacity to biologically reproduce. People with Down syndrome, men and women alike, lead lives filled with relationships, achievements, and deep personal significance. The biological asymmetry we've discussed today is a fascinating and important piece of science, but it is not a measure of worth, of potential, or of the impact that any person can have on the lives of those around them. What this topic ultimately reveals is how extraordinarily intricate and sensitive human biology truly is. One extra chromosome, one small deviation from the standard 46, and it touches the hormonal system, the reproductive system, the developmental timeline, all in ways that differ depending on the biology of the individual carrying it. That's not a flaw in the system. That's the breathtaking complexity of the system, a complexity we are still, even today, working to fully understand. And the more we understand it, the more precisely, the more honestly, and the more compassionately we understand it, the better equipped we are to support every person who navigates life with Down syndrome, in all of its complexity, in all of its richness, and in all of its deeply human reality.